Good morning, children. Today we will study about electric dipole. An electric dipole is a pair of equal and opposite charges separated by some distance. So here, if I have charge minus q and plus q separated by distance 2a, this is called an electric dipole. The effectiveness of electric dipole is measured by a physical quantity called as dipole moment. Dipole moment is represented by a letter P. Dipole moment is a vector quantity whose direction is defined from minus q to plus q. So if P is a vector quantity, the direction of P vector is minus q to plus q. Now the SI unit of dipole moment for this, we need to know the formula for electric dipole moment. So dipole moment is given as the product of the either charge of the dipole multiplied by the separation between the charges. So the SI unit of electric dipole moment is Coulomb meter. Right? Now we will study about the electric field due to an electric dipole at a point on its axial line. So we need to study what do we mean by an axial line and what do we mean by an equatorial line. So for that, let's consider an electric dipole minus q plus q separated by distance 2a, right? The line which passes through this line joining the charges. This line is called the axial line of the electric dipole. And the line which passes through the perpendicular bisector of this dipole, this line is called the equatorial line. Equatorial line. And the plane which passes through this equatorial line is called as equatorial plane. If we consider a plane passing through this equatorial line, then this plane is called equatorial plane. Based on the selection of the point, whether we are taking it on the axial line or the equatorial line, the value of electric field will be different. So in today's lecture, we are considering the electric field due to a dipole at a point on its axis. For this, let's consider a point P at a point on its axis. That is, let's extend this line and mark a point P where we want to find out the electric field due to this dipole. We know that 2a is the separation of these charges and O is the center of this dipole. So this distance will be A and this distance will be A. Let's consider this point as A, this point as B. We know by principle of superposition that for finding the net electric field at a point, we need to find the electric field due to all the charges present around that point, and we have to find out the vector sum of those electric fields. So let's find out the direction of the electric fields due to this minus q charge and plus q charge. We also know that for finding the electric field at any point, we place a +1 charge over there, which is called as test charge. So we are placing a +1 charge over here to find the electric field direction due to this plus q charge and minus q charge. Now, this is plus charge, this is positive charge, both are like charges. So what will be the direction of electric field due to plus q charge at this point? Obviously, this charge will be repelled by this charge. So this will be the direction of the electric field due to plus q charge. Now this is a negative charge, so it will attract this charge. So this would be the direction of electric field due to minus q charge. We know that these are in opposite directions. So by principle of superposition, so E at a point on its axis, by principle of superposition, will be written as E due to plus q and E due to minus q. Right? Now, what is the formula for the electric field? We know that electric field is equal to K Q upon R square. Right? Now, if I want to write the electric field due to plus q and minus q charge, we know that electric field is a vector quantity. So I need to write the direction also. We already know that the direction of dipole moment vector is from minus q to plus q. So to show the direction of dipole moment, I will show this by unit vector p cap, which is from minus q to plus q. Now for writing the electric field vector due to plus q charge, this will be the magnitude multiplied by the direction of plus q electric field. We know that the direction of electric field due to plus q charge is same as the direction of p cap. So we will write down that E plus q is equal to magnitude of E plus q multiplied by the direction of p. This we have written because we already know that any vector is represented as its magnitude multiplied by its direction. I hope you remember this. We had studied this in 11th standard. Similarly, but again here, this is the formula KQ upon R square. Now what is this R over here? We know that R is the separation of point P from the center of the dipole. I am writing here electric field due to plus q charge. That means I have to write the separation of plus q and point P. For this, I'll have to check this diagram. This separation is R. This separation is A. So the separation between plus q charge and point P is R minus A. So I will replace the distance by R minus A whole square. This is electric field due to plus q charge. Now I have to find the electric field due to minus q charge. This will be again K Q upon separation of minus q and point P. This separation, the square of this separation. So what is this separation between minus q and P? We know that A to point O, this separation is A, and from point O to point P, this is R. So the total separation becomes R plus A. So this will be written as R plus A whole square. This is the magnitude of the electric field due to minus q charge multiplied by the direction of electric field due to minus q charge. Let's see the direction. Electric field due to minus q charge is along left side and p cap vector is on the right side. So how will I represent the direction of E due to minus q? This will be minus p cap. I hope it is clear. So let's rub the diagram. Now only the mathematical calculation is left. Now let's consider this as our equation 1, this as equation 2 and this as equation 3. Let's put the values from equation 2 and 3 in equation 1. So from 2 and 3 in 1. What will be the expression? The expression will be E axis is equal to, let's put the value of E due to plus Q. This will be K Q upon R minus A whole square P cap plus, what will be the value of E minus Q? This will be K Q upon R plus A whole square into minus P cap. We can take P cap common. So this gives us E axis. Let's take K Q common over here and P cap common over here. So this makes it 1 by R minus A whole square. Let's mark this as square bracket. And this minus will remain here. So this will be 1 by R plus A whole square. Right? Now simple mathematical calculation is left here. We just need to use whatever mathematical formulas we know. This is K, Q, right? And let's break this R minus A, R minus A. This is R plus A and this is also R plus A. And this P cap remains here. We have taken the LCM and we have broken out because we need to use another formula in next step. So this is R plus A whole square, right, minus R minus A whole square. So this makes it E axis. This is E axis. This makes it K Q, and let's solve it. A square plus B square plus 2AB. Similarly, this is A square plus B square minus 2AB. Now if I open this bracket, I need to save some space here. So if we open this bracket, the sign will be opposite because here this is minus sign. So this will be minus and this will be plus. So this makes it the present form of the equation. And in the denominator, if you look at the denominator, this R minus A, these all four are in product form. So this R minus A can be clubbed with this R plus A. So this makes it A minus B into A plus B is A square minus B square. Another pairing R minus A R plus A will give you another R square minus A square. So this can be written as this. The last step for solving. So now from this, let's mark this as equation 4. So from equation 4, so I'm rubbing this heading since we have to write these steps in continuity. From 4, E at a point on its axis is equal to K cube on outer side, and this R square will be cancelled, this A square will be cancelled, 2RA makes it 4RA upon, this is R square minus A square to the power square into P cap. Now we can write this like this, 2A into 2R. 4R can be broken down into 2 into 2R, and this can be written as R square minus A square to the power 2 into P cap. I hope this is clear. Now from here, this is E at an axis, and this will be K. We know that Q into 2A is what? P, right? And this can be written like this, and here R as it is, R square minus A square to the power square into P cap. Let's take a special case. Special case is the case where P point is very far away from the dipole. Or in other words, we can say that P, the distance of the P point from the center of the dipole is very, very greater than the size of the dipole. So we are using the case where R is very, very greater than A. So we can neglect this. So this makes it E at an axis is equal to K, that means 1 by 4 pi epsilon naught. I am replacing K by this, 2P R as it is. So this is R square to the power 2 makes it R to the power 4 into P cap. So in the last step, we can write down this E axis is equal to 1 by 4 pi epsilon naught 2P upon R cube into P cap. So this is because this is cancelled, and the formula for the electric field due to a dipole at an axial point is this one. Thank you.